Now let us discuss the anomalous behavior of beryllium. Yes, beryllium, when compared with the rest of the group metals or elements, shows anomalous behavior, very different behavior. It shows, of course, diagonal relationship with aluminium also, but we need to first look into the reasons why it shows anomalous behavior. The first reason is its very small size and high ionization enthalpies. As a result of which, what we find is this beryllium shows very anomalous behavior. Its compound shows more covalent character because of the more higher polarizing power, and that this is how its property starts getting changed. The second important thing, which is actually is an example or the explanation of its anomalous behavior, is this, that its oxides and hydroxides, if we see their oxides and hydroxides, what we find is that they are not basic, they are amphoteric. Hydroxides, on the other hand, accepts OH minus ions in water and releases H plus ion. So that's another very unusual behavior from the rest of the group elements and their compounds. Another important thing about this is, the third thing is that beryllium is not able to extend its octet. It's not able to extend its octet. The reason is because it doesn't have d orbitals. As a result, what we find is its salt doesn't get hydrolyzed easily, and it's not able to form the complexes with coordination number more than 4. So this is how, because of these reasons, what we find is that beryllium behavior becomes different from the rest of the group elements, and we call it an anomalous behavior of beryllium.